Hello again. So we are here in chapter 6. It has been divided to two parts, part 1 and part 2. So this chapter is about time series analysis and forecasting. Okay, very interesting topic and very applicable techniques in the life of all of us. So let's get started actually. So yeah, we have different types of data set. Okay, the sales of a store for over the months, over the weeks, is a data series. So, and it is a time series. Okay, so I don't want to repeat the difference between qualitative and quantitative. We have been through it in the first chapter of this book. And among the quantitative, there is a time series patterns. Okay, so any events that repeating over time. So as I said, it can be every minute, like a stock prices, every hour, the same stock prices, oil prices. It can be a daily basis, like a sale of a restaurant, sale of a store. It can be a weekly based, again a demand for anything, any business. It can be also weekly, monthly, quarterly, every 3 years, like economic data, and also yearly based. Okay, so it's very important to know the nature of these data. Okay, so if we are dealing with one data, with one variable, for example the euro-dollar prices over a specific period of time, so this is so-called time series. Okay, so this data is time series in nature. Okay, we have here, okay, this is an example and it's a real example. Okay, so it's a GDP of United States from 1960 up to 2018. Okay, this is a time series data. Okay, however, looking at this data, we don't understand why we are using it. What is that? What that is used for, and how we interpret this. Okay, and the aim is actually through the historical data we may understand the next data. Okay, we can forecast for the next move of this series. Okay, 2019, although these data are given, but what about 2020? What will happen to this? 2021, 2022. So by using this historical data, we can estimate, forecast the next periods. Okay, and this is applicable for any series. Okay, let's say KFC sales. Okay, let's assume that the sales are $25,000, $24 $23. This is random numbers. Okay, $6,000. Okay, so these are in dollars, and those are for let's say May 1st 2020, okay, and we have here 6th May 2020. Okay, so through these historical data and longer data actually back, this is just an example, we may forecast the upcoming days sales. Okay, so okay, we said like we can forecast. There are many methods of forecast. We will go through them, we will test them, we will understand how we do that. But before we get in them, we should know the nature of the given data. Okay, the nature, how we can know that? The best way is to plot it in the graph. Okay, let me plot it here. Okay, so okay, from this one we see there's a trend. Okay, and it is a upward trend, smooth upward trend. Okay, then accordingly we deal with the given data. Okay, so this obviously tells us the next movement. Okay, we will forecast it to be here according to this data. Okay, except for unexpected events like this 2008's financial crisis. So let's get back to this. So we found that like there are many trends. When we plot them, the nature of the data tells us many stuff. Okay, so let me share with you a few more trends, photos, examples. Yeah, so the trends are here. You see, this trend data called horizontal one. It goes okay as a horizontally. So although there is some fluctuations around here, but the trend is horizontal. This is upward trend. Okay, just like the previous example of GDP of the United States. And this is seasonal ones. Okay, this is seasonal. What do we mean by seasonal? Like, we are not meaning seasons like summer, spring, autumn and winter. What do we mean here? We mean that this series, for example, the sales of KFC, if we put them, if we check the real data of the sales of KFC, McDonald's, restaurants anyway, we can observe that on the weekend they are selling very high products, foods, high number of foods. Okay, but in the normal days from Monday to Friday the sale is low. So this gives us, if we go daily, if we check the daily data for this KFC, we will see a seasonal ones, like okay, every weekdays is like this and then rises up. Okay, that will be, for example, in this way. So some Saturday and Sunday goes up and comes down again for this level, and then Saturday and Friday goes up, and then the same. Okay, so if we check, for example, the travel industry sales, like airplanes, so we see like in summer and spring the flights are very, very high, but during the autumn and winter it is silence, it's quiet. So over many years, monthly data gives us a very seasonal data. Okay, and then we have cyclical data, and this happens in response to cyclical business cycle. Over here, business cycle is affecting on this. Okay, and it's very hard because business cycle refers to short-term economic activities. It's very hard to assume or to the next movements, to forecast the next movements of any type of data. However, we don't deal with that one here. Okay, we will focus on the trend and horizontals. Okay, those data are useful in the business analysis and for your level. Okay, and also we have trend and seasonal together, like this data. Okay, it is seasonal one, but it's upward. Okay, this is downward and seasonal. Okay, together. So those can be combined in one series. So here's the umbrella sales time series, which is horizontal and at the same time seasonal. So during the winter, the sale of umbrella rises, but this pattern is like spring and summer, and then it goes up, but overall trend is horizontal. Okay, here are the trends. I just covered them. You may go over them for the detail of my explanation. So as I said, the aim of analyzing any data series is to forecast the next data. Okay, but the forecasting is not out of errors. Okay, so no one can forecast 100% what will going to happen next day or next month or next year. I mean, based on the category of the data that you are using, based on the business that you are in. But the important thing here is to select the best forecasting method. And what is the best forecasting method? The best one is the one which has the minimum errors of forecasting. Okay, how that can be happen? Let me give you. Okay, so here is the small example over here. Just focus on this part, please, with me. Here is a small example. Let's say a kebab restaurant is forecasting the sale to be 45 million dinars, okay, and on June to be 55 million, okay. Then we go there. After we get in July, we analyze whether we were correct in our forecasting or not, okay. The actual sale of this store was 40 million, but the actual sale in June was 60 million, okay. So now the forecasting error is I would say in abbreviation, write in abbreviation, forecasting error is equal the actual minus the forecast one, okay, minus 5. The same here, that one minus this one, no, sorry, the actual equal the actual minus the forecasted one. It is 5, okay. Now, so any forecasting methods that we use and have the minimum forecasting error, that's the best fit one. So that can be applied for the next experiments or for the next estimations of our demand, of our sale, of whatever, okay. So here is the forecasting error, the actual value minus forecast, as we did here, the example, okay. So a positive forecasting error indicates the forecast methods underestimated the actual sale, okay. Here the actual sale has been underestimated, 55, but the actual was 60, and vice versa, overestimated in this one, okay. So what are the mean of errors? The mean of errors when we have a series like this, or we can have 12 months, for example, for this kebab. So we take the average mean of errors. So this negative cancels the positive. So we will have a kind of very close to 0. Okay? Very close to 0. So therefore, it's better to use the absolute value of it. What do we mean by absolute? The absolute is with no negative sign, all positive. And then we understand how much we made a mistake. So what's the difference? Like we have minus 5 here and 5 here. So both are different. Both are 5 million dinar errors in the forecasting. Okay, so you take the absolute mean error for a series, okay, and then another method to overcome these negative signs and other signs is to square them. Okay, so don't get confused. I'll solve many problems on this, so you understand what do you mean by mean error, forecasting error, and mean absolute errors and squared errors. Okay, so squared errors is also another one very, very important. Okay, and then we calculate the mean absolute percentage error. Okay, So mean of the absolute purchased percentage errors. Okay, these are very helpful to give us the best forecasting. Okay, so now how do we make our forecasts? How do we make our forecasts? There are many methods, as we mentioned. So we start with the simplest method, which is naive forecasting method. Okay, naive forecasting method. Okay. So what does this tells us? Ft plus 1 forecast t plus 1, it means one step ahead period. Okay, if we are dealing with daily data, it means tomorrow's one. If we are dealing with the weekly data, next week. Monthly is next month. Okay, so the Ft plus 1 data equals to the previous most recent data. Okay, so here is headache medicine for a pharmacy store, you know, so they expect the sales to be in this way. Okay, so let's find all of these stuff. So I'm giving the example over here. Okay, and this is the answer, but how we get there, we'll go over there. Okay, so as we said, the forecasting for the week 2 sales is to be like the previous week. This is the simple estimation method. And the forecasting of week 3 is to be like the week 2 sales. Okay, and the same up to week 10. Okay, so we made our forecast over here. Okay, so what's the forecasting error? What's the forecasting errors? The forecasting error is, as we said, the actual sale in week 2 minus the forecasted sale in week 2. Okay, we expect the week 2 to sell 110, but actually we sold 115. So this is the forecasting error. Okay, I'll drag this down to get the other forecasting as well. Okay, and now what is the absolute error? As I said, in order to be free from the negative points signed, we will get the absolute value of the forecast errors. Absolute error. Okay, this is absolute error. And now we have 5, 10, 5, 5, 5, 10, 15, 5, 20. Okay, so the total is the total of these are 80. Okay, the sum of all of these is 80. Okay, and now we have squared errors. We have squared errors. So to the power of 2, we make squared errors equal this one to the power of 2, 25. We drag this down up to here, okay, and then drag this to the right. So there's a mistake over here. I don't see any mistake in my calculation, but the example of the book is given us to be 850, so I will go with 850. Okay, and we have the percentage change of absolute errors. So how we calculate that one? We have the absolute error divided by So how we calculate this actually? So to find the change, percentage change of absolute error, we're gonna divide the absolute error by the actual value, which is here sale. Okay, and I'll drag this down up to here and then copy this here. So here we go. Okay, we are here. Okay, and this one is almost 65%. Now, how we find the mean of absolute errors? Mean of absolute errors. It's here. We divide. We have 9 observations over here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we divide this by 9 and we get that one. Also we have the mean of squared errors. We divide this by 9. Also we have the mean of absolute percentage errors. We divide the sum of the absolute percentage errors by 9. Okay, so that's how we calculate these tables. Okay, so what is that numbers telling us? For now it's nothing. It's nothing unless we use another method for our estimation and find the mean of forecasting errors over here. Okay, absolute errors, squared errors, and percentage of absolute errors. So the one with smaller, the one with smaller forecasting error is the one which is the best method. Okay, that's how we do select which one is the appropriate method of forecasting in our case. Okay, so that was one. That one was naive forecasting errors. Naive forecasting errors. But that's the simplest one actually. So now we move to the better ones over here. Yeah, that's the calculations, the numbers that have been obtained. Okay. Okay, so what are the bets? The better ones is moving average and exponential smoothing. methods. Okay, moving average and exponential smoothings. And also we have moving weighted moving average. Okay, so how we do that actually? So how we do that? Let's see how this moving average works. I'll go over them one by one. Okay, so it's telling us that, let me get to this moving average. Okay, yeah, okay, let's have the same data over here and examine the forecasting using the new method, which is moving average. Okay, so here are weeks, moving average. So this one tells us that this is a mathematic calculation. Okay, so we forecast plus 1 is the average, of the most recent datas. Okay, so f plus 1 is the average of the most recent datas that have been given. Okay, the most recent k data values divided by k. K means how many weeks in this case we select. Okay, how many weeks? Let's assume here's moving average, and assume k equals to 3. K equals to 3. Okay, so we skip 3 weeks and forecast the 4th week over here. Okay, this equals to the week 1 sale plus week 2 sale plus week 3 sale divided by K3. Okay, here it is. Here it is. Alright, and we continue with our example and estimate this one. And then the same, I'll drag it down, the same calculation over here. Okay, let's do it manually and you understand what's going on. The forecasting of the 4th week's or the 5th week's sale is, so it is 4th week's sale plus 3rd week's sale plus week 2 sales divided by 3. Okay, I think there is a mistake here. Okay, so the same for the rest of the data. Okay, the same for the rest of the data. Okay, doesn't matter. So what's the forecasting error? The same method as we did, the actual one minus the forecasted one. Okay, over here. So what's the absolute one? Okay, because we have like decimal numbers here, so I will use absolute function in Excel absolute of this is this, and we drag down to get the rest. Okay, and here we have the sum of the absolute values, which will be 53.3. okay, the same is obtained here. And then the same as we did for naive method, squared errors is equal to the absolute error to the power of 2. Sorry for that. And let's drag them down. 25. $69. So my numbers are a little bit different from the one of there, and that happens because they are skipping these over here. Okay, like if I do it manually, so I'll get the same number as they do. Anyway, so the sum is 489.45. Okay, and then what about the absolute change errors? So that's equal to absolute error divided by the actual sale, the actual value, whatever it is. Okay, so we are here. Some numbers are rounded over here, so don't get confused. Okay, so now how many values we have here? 1, 2, 3, 4, 5, 6, 7. So we divide mean of absolute errors divide by 7. The same squared, the mean of squared errors divide the sum of squared errors divided by 7, and then the mean of absolute percentage errors divided by 7. Okay, here we are. So okay, so now let's compare what we obtained from naive forecasting and moving average forecasting. As we see, the mean of absolute errors here is smaller than this one. Okay, okay, and this one, mean of squared errors is smaller than that one. Mean of absolute percentage errors is also smaller. So the moving average method of forecasting is better forecasting method than the simple naive one. Okay, that's how we conclude. What about weighted average, weighted moving average actually? So we will assign a weight for them. The weighted moving average is looking like the expected value that we used to use in the previous chapters for the probability calculations. Okay, so we assign a probability for each of these values that we have over here. Okay, so how we do that, for example? Okay, here is again three moving average but with weight. Okay, so we have here the calculation that 0.2 is, it can be 110 week 1, 0.3 can be 115 the week 1, and the 0.5, which is the most probability, is a recent observation. Okay, because this is just last week and this is the closest one to this week, so we weighted 50%. So this weighted average, so these weights are up to the managers, up to the decision makers, how they select it. Okay, but here we are just showing how to calculate, but it's up to them, up to their experience, up to the experience of the managers, historical data that they have, and all experience actually. So you find here the week 4 is expected to be 119. It's the closest results that obtained up to now. Okay, so here is the calculation. Here is the calculation. Okay, the same way as we did. I don't want to repeat them. The thing is just I want to highlight some over here, like the forecast sale of week 5 contains the weighted average of week 2, 3, 4. So 0.2 goes here. If I could extend this one, 0.2 goes here, and 0.3 goes here, and 0.5 goes to the recent one. So we obtain 120.5. Okay, the same measurements, the same way we measure the forecasts over here. Errors. Okay, here is that one. Okay, now as I said, okay, we do our calculation and we never know whether this is better than the other one unless we compare the mean of absolute errors, mean of squared errors, mean of absolute percentage errors to the previous method. Okay, so mean of absolute errors give us kind of little bit higher than this, and mean of squared errors is also higher than moving average. Okay, and mean of percentage errors also more or less the same. Okay, so the moving average with the 3K is better estimation of weighted moving average in this case. Okay, now we move to exponential smoothing method of forecast. Yeah, so exponential smoothing. So before I get in the mathematical adjustments for it, I can show you, sorry for that, I can show you how this works. For example, we have a series in this way. Okay, now when we use the exponential smoothing, it smooths the series. Okay, so we have many fluctuations as you see over here. Although we have upward trend, that's fine, but we have many fluctuations, deviations from mean. Okay, it makes it in this way smoother. Okay, smoother for us. So better forecasting can be obtained over here. Okay, so let's see how it works. We have basically this equation for forecasting. Okay, so forecasting t plus 1, one step ahead, equals alpha gamma t and plus 1 minus alpha ft. Okay, let's see what are those. Sorry, here. So gamma t is the actual value of the time series in the period t. In this case, if we wanna estimate here week 3, let's say, so gamma t is 110. It's the forecasted one. Okay, it's the actual value. Okay, and then plus 1 minus a ft. Okay, so a should be any value. It's a probability, it's a weight over here. Okay, it's a weight over here. So let's see how that works. You understand better while we do it, apply it here. Okay, so a in this example, a is 0.1. Okay, so a is 0.1 multiple by the actual value over here, plus 1 minus a, it means 90%. Okay, here is 0.1, that will be 90%. Okay, if a equals 0.1, 1 minus a will be, we know that, and we learned that in the game theory, 0.9. Okay, so let's see how this works. For the case of simplicity, we can see the detail of them. Here we put gamma over here. Why? Because we don't have previous forecasting. Okay, in F2, but we go to F3 and we calculate 0.1 multiplied by the second actual sale plus 0.9 multiple by, sorry, multiple by sorry for that, that's okay, multiple by gamma. So we obtain 110.5. Okay. Again, we have here using the same method. Okay, I'll do this one manually in order for you to understand. Equal 0.1 multiplied by the actual value over here, 125, plus 0.9 multiplied by gamma, and we obtain this number. Okay, I'll drag this down in order to get the rest of the numbers. Okay, if we have if we assign A probability to be 0.8, we will get this number. Okay, we will get this number. Okay, then we will go for the forecasting errors, equal the actual sale minus here the forecasted sale. Okay, here I draw down here, equal absolute value of errors. I drag this down to get the rest of the results. Okay, and now the squared one equals the squared errors to the power of 2. I'm getting these numbers. Okay, and here is the absolute percentage error equals the absolute error divided by the actual sale. Okay, I'll drag this down too. Okay, now let me remove this one. The sum is 82.95974.22, 0.6698. Okay, because this is percentage. Now let's equal to this divided by how many values we have here, 9 actually. Okay, same is here, the sum of them divided by nine, and that will be also 0.744. So okay, we used this one. Now what about when A is 8? We obtain these values and we have the mean of forecast errors over here less. Okay, so comparing this one with the other one, this is the best actually. So the model that we established and forecasted with A equals to 80% here is better than this model that we have been through. Okay, so now optimal smoothing constant value. So optimal smoothing constant value is the one that we have to try. For example, I'm telling you A to be 0.1 and A to be 0.2, for example, A to be 0.27. So it's a kind of modeling based on trials and errors. Okay, so we try and get error, we try and get error until we get the minimum mean squared errors from each estimations, from each forecasting. Okay, when we reach to that point, so that's the best model and we can go and work on it. Yeah, that was it. Thank you very much for your attention. So in the next video I will let you know about the selected problems and solve them for you, which you will be responsible on it. Thanks a lot.